It's a very important. Today we start chapter 22. P-values. P-values. All these are building on previous understanding. So what is a p-value? Let me give you an example. Let me give you an example. Let's say these are the university A. I don't want to give the name of the university. This is one university, and in this university, students' performance, let's say exam is 60, so the mean is 60, okay. These could be the proportion, okay? Maybe 40% in this university, 40% students exam is 60, and here, and let's say is 1 sigma away. Let's say is 70. So in this university, the mean is 60, mu is 60. Standard deviation, sigma is 10, okay? Let's say, so it's 50. And this is a 1 sigma away, okay? Steepest, the slope, the steepest, use your finger to trace the normal curve. At the steepest one, this distance is a sigma. And 2 sigma away, what's the score here? What's the score here? Is 80. And what's the score here? 40. Okay. And so this is all the story. Now, the rule, the 68, 95, 99.7 rule. So this part, in 1 sigma, this area is 68%. Okay. And for 3 sigma away, what's the score here? is 90. Okay? What's the score here? 30. Okay. This is the old story. Old story. Now, a student, a stranger student, his score is 90. Let's say John. His score is 90. We don't. So, is this student belongs this university? Is this student belongs to this university? His score is 90. So it's here. Okay. The probability, what's this part? What's this probability? What's this probability? What's this probability? Okay. So, what's the probability here? What's the probability here? This one plus this one this, the red one plus this one is left over of this. Okay? Doesn't look green. Doesn't look green. I hope you can appreciate the green. This one a little bit tail and plus the little red tail. The total is 0.3%. The total is 0.3%. And for red alone, just for red alone, is what? Is 0.15%. Are you following me? Because this one and this one is 0.15%. Okay. It's 0.15% plus 0.15%. So it's 0.3%. And for this part, it's 0.15%. So if John belongs to this university, the probability is what? The probability is what? The probability is Z. Is 0.15%. This is called p-value, or you express it is 0.0011. This is a p-value. This is a p-value. So the probability for John to belong to this university is very, very tiny. It's a very, very small chance. In daily life, so when something is less than, when something is less than 5%. Oh, no, not 5. Is 5%. Then we reject. If less than 5%, then we say we don't believe it. We don't believe it. And John's probability is even smaller. Is even smaller. So we say we don't believe John belongs. We don't believe John belongs to this university with the p-value equal to this. It's a very, very small chance, very, very tiny chance he belongs to this university. This is the p-value. And it's a big deal. People write a book just talking about p-value. Just talking about p-value. This is a weird shopping mall. This, no matter who it is, I cannot recognize. And I have a feeling who it is, to be honest. Okay, this is the first time you see the p-value. This is the first time you see the p-value. And let's open your textbook. Let's open your textbook. Chapter 22. Go to chapter 22 on your textbook. And look at that example, the fresh coffee. The fresh coffee. So they're doing a research. Say, do people really prefer the fresh coffee? Do people really prefer, or they don't care? On page 482. On page 482. On page 482. The example 1. Example 1. getting serious. I just say, look, hold on. Go on. Go on. No, no, no. Example one. Is the coffee fresh? So they want to study, do people really prefer fresh coffee? Do people really prefer fresh coffee? So they randomly selected 50 volunteers to do the test. And they have 2 cups of coffee, not telling the volunteers which one is fresh coffee, which one is instant coffee. And so after they tested, at the end, 36 out of the 50, they're chosen the fresh coffee. They chosen the fresh coffee. So, okay, this is the result. So what's the conclusion? What's the conclusion? So you can say 72%. You say, wow, 72%? Because 36 out of the 50 is 32%. You can say, oh, yeah, teacher, 72%. Yeah, I believe that. People prefer fresh coffee than the instant coffee. But I'm asking you, if it's not, let's say, 50%, if half people chosen the fresh coffee and the instant coffee. This means that people don't care. This means that people do not care. Okay? But if you did the experiment, is 51% people like the fresh coffee. Can you reach the conclusion? Say, oh, yeah, people like fresh coffee. Can you reach the conclusion? No, because there's a random chance. It's a random chance. It's like you are throwing a coin, a perfect coin, okay? Ideally, it's a 50% being head, 50% being tail. that student, what's his name? Asel. He has been absent for many, many times. More than 50% time. He is not behaving well. This is why I do not do. He's consider the class policy as a nothing. Consider the class policy as a nothing. So let's say a coin. Let's leave alone the coffee story for a little. Let's say a coin. Ideally, you should get 50% when you throw it. But if a coin you throw 100 times, you got 51. You got 51 ahead. Can you, based on this, say this coin is unfair? Can you see? No, right? Because it is by chance you throw 100 times. Even though ideally you should get 50 times, but in real life you maybe get 50 times. Head. So for such small change, you cannot say, then how about 52%? Which means when you throw 100 times, you get 52. Can you say this tail is a bias? Can you see? How about 53? If you get throw 100 times, you got 53. How about 54? So how about, I keep going, how about 60? When you throw 100 times, you got 60 times. Do you think this is a biased coin? Mm-hmm. How about 70 times? How about 70 times? We need, in somewhere, how about 80 times? If you throw 100 times, 80 times is ahead. How about 90 times? How about 90 times? How about 90 times? How about 100? You throw 100 times and 100 is ahead. In somewhere, we have a cut off. We have a cut off. Say, teacher, stop it. I believe this coin is a cheating coin, is not a fair coin. In somewhere, we have to stop it. But this cut off has to be done mathematically, not by the feeling. Oh, this is not right. Is this a coin? Is this a fair? Shouldn't be 60%. But could by chance, there is some. Okay, then go, wow, throw 100 times, 70 times ahead. Oh, I cannot believe this is a fair coin. We cannot just by feeling. We cannot do by feeling. We need to do it mathematically. back to this coffee. Back to this coffee. That we suppose, in the beginning, we suppose the people do not care. 50-50. 50-50. And the result is 72%. The result is here, 72%. The result is 72%. So can we say that this coin is really has some preference? Can we say this coin has some preference? So how do we do it? We do it by p-value. This is a big deal. This is a why p-value is a big deal. So I erase this and another normal curve. Another normal curve. And let's assuming people do not care. There's no preference. People do not care fresh coffee or instant coffee. So it's a 50%. Okay. But sometimes why is not fixed? Why is not fixed exactly 50%? Why does it sound like 40 something, 50 something, or even 60? Because, maybe that's the way we go into the two columns. By some random chances, that we maybe in this class, maybe is 58%, like let's say we don't care, but by chance, could be higher, could be lower. Oh, I should write down the two formulas here. I should write down the two formulas here. There was a remember this formula? The standard deviation, this part is a standard deviation. This is for the proportion. We're dealing with the proportion right now. And for the mean, the mean is valued x. and standard deviation divided by 3. The two-bit formula here. Okay. So for this test, 50 people, what's the standard deviation? What's the standard deviation for this test? You guys are good with it, don't you? What's the standard deviation? What's the standard deviation for this test? Standard deviation. Standard deviation. What is the standard deviation? What is the standard? If you have not done the homework, don't do it now. Really. If you get lost for the p-value, it's dramatic loss for you. It's dramatic loss for you. This is the most important in statistics. This is the most important in statistics. If you do not understand it today, then I guarantee you, you will not understand for the rest of your life. People cannot explain p-value well. If you just Google it, if you just go to the YouTube, you will get more confused. You will get more confused. So for this model, we are assuming this is called a non-model. Non-model. In this model, we assuming people do not care. 50%. Sometimes a little bit less, sometimes a little bit more, but basically people do not care. In this model, we are assuming this. Based on this model, what is the standard deviation? What is the standard deviation, guys? I borrow space here. I borrow space here. I borrow space here. What's the P? The proportion. Is that a 0.72? Is that a 0.72 or is 0.5? It's 0.5 because we are assuming do not care. Is this model, not another model, okay? We are assuming people do not care. Okay? So it's 1 minus 0.5. What's the n? What is the n? drive home, Z. What's the number? What's the number? It's on the book. Yes. Thank you. And look at here. Look at here. I'm sorry for online students. If we have a curtain, maybe they don't see. They can see it better. Look at that. Do you see it? The standard deviation. You want even larger. You have better eyes than me. Do you see it? They don't use S. I just use S, standard deviation. You drive home and it's 0.0707. This is the standard deviation. Okay? And I just use decimal. It's the same thing, okay? Here is 0.5. 0.5, 50%. So if I use a finger to trace it, here is a steepest. What's the value here? What's the value here? Huh? Is the ones? What's the value here? Oh, come on. Is a 1s, one standard deviation. One standard deviation. So it's a 0.507. We stop here. That's okay. We can write, but I don't have the space. Okay. And here, what's the value here? 0.43. Okay. And if 2 times, what's the value here? If it's a 2, what's the value here? If it's a plus. If it's a plus. Why this twice is this? Right? Yes. I'm sorry. Okay, so what's the value? What's this value? 0.64. Okay. And here there's another value, and I don't bother with this. Okay. So what's here? If 3 times, what's the value here? What's the value here? 3 times, okay? 0.71, okay? 0.71. And if you do a little bit of rounding, almost 0.72. Anyway, okay, I'm bother with it. So it's 0.71. Do you see it? And what's the probability for this small tail? What's the probability? What's the probability for this little tail? three voices. What's the probability? What's the probability? This a little bit tail plus this a little bit tail is 0.3%. This a little tail is 0.3%. Because they are symmetric, so the two are equal. For this one is a half, 0.15%. Do you see it? For these guys, what's the result? We got a 0.72, right? We got a 0.72. Do you see it? 0.72. So 0.72. The chance those people in this model, the probability is, let's say, is similar. The probability is this. Okay? Which means if people do not care about the fresh coffee or instant coffee, if people do not have any preference, the chance to get 72% to choose the fresh coffee is this. It's very, very small. It's very, very small. So we can reject, say, this is not true. We can reject, say, this is not true. This null model is not true. Okay? So we say the bottom line is people do have preference. People do have a preference to the fresh coffee. People do have a preference. So there are the real situation is another model. Our conclusion is this is wrong. Reject. The real situation is somewhere we do not know here. We do not know here. Maybe it's 70% people. Maybe it's 70% people prefer the fresh coffee. Okay, it is impossible. 50% people prefer the fresh coffee. Is another model. The real situation is maybe 70%, maybe it's 80%. Okay, we do not know. This study just to kill this null model, and showing that the people have the preference to the fresh coffee. Okay, we take a break now.